All right.
Evening, you all.
Okay, thanks everyone for coming. Tonight we're going to be talking about Wave, and thankfully I'm not talking in this one because I haven't prepared anything. Terry, perhaps should we start with you, and you can introduce who's going to be talking tonight, and kick it off.
Yeah, thanks on behalf of everybody, Tim, for organising this to kill the boredom of the lockdown. We've got Alex McCaw on the technical stuff in the middle of your screen there, and he's going to be flicking through some pictures and screenshots and what have you with his little pointer as our speakers go. I've got three gentlemen who are going to be telling us their stories on the wave flying. There's Rangi Diafaby, there's Vaughan Ruddock and Mike Oakley. Rangi's got a good story to tell. He's a 1,000k and 1,500 kilometre diploma man. Vaughan's a multiple New Zealand champion and 1,000 kilometre pilot, and has done 1,000 kilometre out of Paraparaumu, which is quite an achievement. Mike Oakley, also multiple New Zealand champion and 1,750 kilometre diploma, experienced wave pilot, and has had a world record in the past. These guys are all good at what they do. They all know what they're talking about, and hopefully they've got some stuff that can pass on. They'll talk about all sorts of aspects of using the wave, anything from how to get into it for people that aren't really wave pilots. And they'll give you their techniques on how to use the wave, how to travel fast along it, how to get the best distance, how to maximise the day with the use of the wave, and how to do it safely, because that's quite an important thing. You want to come back safe and sound at the end of the day. There's a chat button at the bottom of your Zoom screen for questions. If you hit the chat button, if you've got a question, then you can hit the chat button and type your question out to whoever you want, to the three speakers or to any one of them in general. If you've got a burning question, then you unmute yourself and just burst in. We want to have questions and answers at the end, so there's a little interaction with this thing. So we'll kick off with Rangi for a start off. And as you'll see, surprise, surprise, Rangi is a white man. He's a good pilot. He's our ex-CFI, and he's going to do what he does. Rangi, away you go.
Okay, thanks for that, Terry. Right, so I was asked to give you guys a little bit of a chat about what I think about flying in Wave. Just one thing I noticed though, if you do chat and send a message, I think you have, after you've typed it, you have to push enter for it to get. Okay. Yeah, so first thing I'll start on was airspace. Now, as far as I'm concerned with airspace, there really isn't any issues. You just go onto control and then you can go and fly where you want. So if you haven't done this before, well, you need to get used to the idea of what you need to do. And I think to start with, the first thing you need to start doing is referring to your glider as Golf, whatever the rego is. So always call it Golf Charlie Victor or Golf Papa Bravo instead of just Charlie Victor and Papa Bravo. Then you won't sound like a dick when you first get on control. So if you think there's wave, if you know where there's wave and you can climb and you want to climb higher than you're allowed uncontrolled airspace, then just go to that area and get on to control before sometime well before you actually get into the controlled airspace or are going to. So, and make sure that you're outside and below the controlled airspace, turn on your transponder and radio to the ATC frequency. And if you're, depending on your transponder, some of them take a while to warm up, the older ones. So you need to have that all up and running. And just listen out on the frequency, and when there's a gap, call them up. So in this case, for me to go onto control, It'd be Christchurch approach, Golf Charlie Victor. They'll come back, go ahead, Golf Charlie Victor. And I go, I'm currently about 5 miles west of Springfield at 6,000 feet on a cross-country flight to Marama, or you could say just local soaring, squawking 4321, request clearance to 12,000 feet. They usually would reply, Golf Charlie Victor, cleared to 12,000 feet VFR, local QNH 1011. And you have to read that back, cleared to 12,000 feet VFR, QNH 1011, Golf Charlie Victor. And then you just got to stay on that frequency or any other frequency they direct you to while you're on controlled airspace until you go off controlled airspace, having told them what you want to do. You can usually call them and increase this height. 12,000 feet is not very high in wave. And the other thing is, don't turn the volume down on the radio, just keep it where it is so that you can hear it throughout the whole flight. I tend to write down the clearance and update it every time it changes, just so I've got a record of what I was cleared to, because it might not change for a few hours and then it might change a couple of times. You can always ask ATC for your confirmation of your current clearance. You also need to tell them where you're going to go, which I did, to Marama. But if you change your destination or reach it and want to go further on the same track or want to turn around and head back, let them know. One controller was a little unhappy when I got to Oamaram and I just carried on going down south. So if you reach your destination, then let them know where you're going to go. If going for a long badge flight or record attempt or something special, then phone the duty air traffic control duty manager the afternoon before you go. Let them know what details of what you're trying to do. Send them an email with details as well, including your task sheet, etc. Thank them for their help at the end of the flight and send them an email on how you got on. So ADC can actually be quite helpful. I haven't really had too many problems anywhere along the way. So there's just a few things that have happened with me flying. I was actually flying at somewhere around Springfield, probably in the tallest wave, and I was up 20-odd thousand feet. I can't remember what my clearance was to at this stage, but we'll say it was 21,000 feet. And the controller called me up and gave me a clearance to 22,000 feet just as I was pulling the air brakes out and pushing the nose down, having seen I'd just busted airspace. So he gave me clearance to a higher altitude before I did, which was kind of handy. On a 1,000K flight, I descended through 7,000 feet around Mount Lyford. The controller advised me I was soon going to drop off his radar, and that my clearance to flight level 180 was being removed. They also said that when you climb back up again, just call and we'll just re-clear you back up to flight level 180 again with no problem. And that's just what happened. And then another one was I was flying, this was in 1500, I was flying down from Lake Ohau down the Diadem Range, Magic Mountain area. In that wave there, and then tracking left to get into the Dunstan wave around the corner. And the controller called me up and told me there was no restrictions on going through Queenstown airspace if I wanted to, because I was sort of going around a corner where instead of tracking straight on. So of course she didn't realise that I wanted to follow where the wave was, but you know they were there to help, so to speak. Couple of things when you're flying up high, look at your transponder and the flight level it's putting out. Be aware that altimeters might not be very accurate up around the 20,000 foot area. Some of them are only rated to 20,000 feet. I've had a problem with that once before. I usually get a clearance 1,000 feet above where you want to fly, as if you get into stronger lift, you tend to just push the nose down a bit and fly a bit faster, but then the lift gets a bit stronger, so you repeat, and very soon you find that you're at VNE, but don't want to bust airspace, and you don't want to pull your air brakes out open at that speed. So if you fly 1,000 feet below what you're cleared to, you've got two options. You can either ask for a higher clearance, or you can slow down, pull the air brakes out, and bearing in mind that you'll gain close to 500 to 1,000 feet when slowing down to 70 or 80 knots. Weather, yeah, I'm not very good at weather. I usually look at SkySight, RASP and METView. I use SkySight more, not for where it says the wave actually is, but more for a general indication of how good it probably will be and how far the lift extends. So what conditions are best? From what Terry said in the past, northwest winds down here give the best wave, but the air is more moist as if the air has come from closer to the equator where it's warmer and therefore holds more water vapor, hence more clouds in the way. More westerly flow gives dry air mass, but the wave is usually not quite so good. Oxygen, I use Mountain High EDS with a backup of Mountain High, constant flow, and a mask. So one of the things you need to do is make sure that you have enough oxygen while you're up there if you're on a long flight. And so Mountain High usually rate the amount of hours you get out of a cylinder at 18,000 feet. So you might get 12 hours at 18,000 feet, but every 5,000 foot of altitude you go up, that drops in half. So at 23,000 feet, you've only got 6 hours. At 28,000 feet, you've only got 3 hours of oxygen. Conversely, if you go 5,000 feet below 18,000 feet, you've got 24 hours of oxygen. So you need to bear that in mind. And if you're going to fly high for a long time, you need quite a bit of oxygen. Sometimes you find things are getting a bit tricky up there and it's quite hard to make the odd decision. Even relatively simple things, this usually means that you're a bit low on oxygen, could do with a bit more. What else we got here? So yeah, you want to you can use a cannula up to about 18,000 feet. That's what it's rated for by the FAA in America. And higher than that, you should be on a mask. Preparation for long flights. The first thing really I think is the glider has to be comfortable. You've got to be really comfortable sitting in it. Confor foam is pretty good to help with that. Got to carry water. You probably need to look at any little places your arms are resting on, hard surfaces or whatever, because they get sore after a number of hours, and a little bit of foam packed here and there helps stop that. You want to have preloaded the various ATC control frequencies into your radio if you can. You need to know how to adjust your radio and transponder while you're flying, and of course anything to do with your flight computer as well if you're using one of those. For me, the preparation started even earlier than that. When I first sat in Golf Charlie Victor, before I brought a share on it, I sat there for 2.5 hours and it killed my back quite badly for a wee while. And eventually what I did was I made the same seating position that I had in Golf Yankee Hotel, which was the LS4, and basically moved that same seating position into Charlie Victor, and that fixed it. That was sort of made with packers out of hard foam and things like that. And duct tape. Got to use duct tape. The other thing that's quite handy is having a really quiet glider that helps you hear the radio, since you're going to be staying on the radio all the time with air traffic control and you don't really want to miss what they're saying. Keep yourself out of trouble. And the other thing I do, I often carry a handheld so that I can hear what's happening on the local glider frequencies. Get a little bit of information coming in, because of course you can't hear any of that while you're on control otherwise. Batteries for gliders, need plenty of power for long flights. Lead acid batteries, not so good in the cold. The voltage drops off and you end up not having a great amount of usable electricity. The lithium
Rangi,
ion.
sorry to interrupt you there. What Rangi's really going through here is how important the preparation is. And I think that's part of Rangi's success. He put his mind to getting a 1,000-kilometre flight, and he pretty much achieved it in a short space of time. He skipped to 1250, went straight to 1,500, and that's not easy. It's and he managed to achieve that. So, can you just give us a brief on that one, Rangi, for us? Because I mean, that's quite a
On
good
which
story.
one?
On both of them, like just how you went about, just the
Well,
fast track to that.
yeah, okay. Well, yeah, I'll do a bit on that, and then I'll come back to another thing or so. Yeah, so the 1,000K flight, well, that was pretty easy because, I mean, part of the problem was actually getting the information into your head, and you can only build up so much information over so much time. However, I was pretty lucky and did just a few flights, handful of flights with Terry, and that, of course, helped. So on the 1,000K flight, Terry just said, hang on, we'll get there. Terry said, fly here. So we started off at, I assume you can all see this. You can see the trace, Terry, nod your head.
Yeah. Sorry, I was trying to unmute. Yes, yeah, we got it. Yep, we can see that.
She said, oh, just fly from Russell's Peak up to Wave Hill here. Well, there's two. There's Wave Hill's the furthest one. Then go back down to Mount Hutt. Which is there, turn point. Back up north. And then back home. And so I did. I had a little bit of trouble on the way up. I ended up over here at Mount Lyford, and I was about 7,000 feet or something, and I was out of the wave and couldn't really climb. And so, I mean, wave forms, I've never flown here before either. At that time, wave forms downwind. So I flew downwind, hoping to find wave, which I eventually did, climbed back up and went up. And so the leg up was a bit hard. The next two legs was really easy, and the last leg was hard because there was a front coming up. Now, one thing I should say about this trace is it's netto. And if you look on the right-hand side, you'll see that at about 2 knots, it's a fairly light yellow color. So everything else here, and if you're flying at 65, 70 knots, everything else here is lift. So there's huge amounts of lift here. Everywhere there's lift all the way. There's just shitloads of it.
So Rangi, it's important to know where you're going to get that lift, though, isn't it? So you don't just blast out there and do it in one go. You take one leg at a time until you've stitched the whole thing together.
Yeah, I mean, the first leg is the slowest and more difficult, but of course you're just going downwind of a hill and flying basically parallel to it, and the wave is somewhere along there. But of course, depending on if you've got a flight computer, it leaves a nice trace, and it tells you where the lift is for the next time you go up that way, which helps a whole lot. So I guess there's a couple of things. So that's just really handy for us at Springfield. Springfield's just here, and just here is Torless, and the Torless gives a really stonking wave. So here we've got lift of 14 knots, 16 knots.
Right, Rangi, we're going to run out of time. If you can move on to the, just move along a little, if you will, to your next thing where we've got to fit the other boys in.
Yeah, okay. This one, one thing I was going to show you was the effect of flying high and why you would want to fly high. If you fly high, the effect basically increases your LD relative to your indicated airspeed. This is for my glider, but if we fly at an indicated airspeed here of 65 knots, we're flying in wave, track over ground, 225 degrees, which is basically 90 degrees relative to the northwest. And we're flying, the wind's from 300 degrees, so we've got a slight headwind. So if we at 10,000 feet and the wind speed's 40 knots, we've got an indicated airspeed of 65 knots. Our LD over the ground is 37. However, if that's at 10,000 feet, if we go right up to 20,000 feet, we've still got an indicated airspeed of 65 knots. Our LD over the ground is 40, and our ground speed's 133. So you gained a whole lot there. And then the other one is if we look at, we fly 10 knots faster, the LD just drops off a couple of points, and then 85 knots indicated, but more. However, when we go over on this other side, we're 10,000 feet, 15,000 feet, 20,000 feet, wind speed of 60 knots. If we flying on that same course, indicated airspeed of 60 knots, our LD over the ground is 23. However, if we fly at 75 knots, our LD over the ground is higher, 26. And 85 knots, it's only a little bit different, 25. Then if we fly really high, we'll go 20,000 feet, basically our LD doesn't change with speed much. However, our speed over the ground goes right up to 163.
So the short answer is the altitude is king, isn't it? That's really what you want to be doing. Yeah,
because your true airspeed increases 20% per 10,000 feet above sea level. So at 20,000 feet, you're roughly, your true airspeed is actually about 40% higher.
All right. Okay. What else you got there, Rangi? Because we're just got to move on to the other boys now.
The only other thing is 2,000, if any, not that, the 1,500, that's the only other one. So I guess the other thing was I did a 1,500, and again, that started at Springfield. You can see the tracks, you can see how much lift there is. This again, netto track. Important things are when you're in sync and you want to, you fly directly into the wind. Doesn't last very long that way, like here, here. But there's just heaps and heaps of lift all the way down. All this is a, it's just a milk run all the way down here, all the way along here, all the way back. So my next plan, of course, is to try and do 2,000. And the really easy thing I think about that is all I need to do is join the 1,500 and 1,000K together, basically fly to exactly the same places, and it's done. So there's just heaps of lift around with the wave. The other thing about flying really high is at 20,000 feet and still air, you've got a range of about 300 kilometers. So you're actually often, even though you're down at Omarama, you're actually gliding range of Springfield. You've got this huge range. So that makes life a lot safer. Right, I better be quiet and let somebody else have a go.
Thanks very much, Rangi. Now we're going to skip to the North Island. And if you just click your screenshot there, Rangi, right. And we'll get Vaughan on. And Vaughan's going to tell us a bit about the North Island flying, and he's got some photographs also.
Right, I've got to remember how to get rid of my screen.
Then we'll tell you, or Alex will tell you. Actually, probably, well, just before we go to you, Vaughan, I should have started actually with, Alex has got some sketches of how the wave works, just in brief, just so that people that aren't really up with the long distance cross country flying have got a bit of an understanding about what we're talking about. Can you bring that up, Alex? Just just for a minute or two?
Yeah, no problem. So we probably jumped into that the wrong way. We went to Rangi, who's a great wave pilot, but probably on the more advanced side of things. We should have probably just started with some quick diagrams of how wave works, and in particular in New Zealand. I know we've got a few guys from Australia listening in, so hopefully you can all see my screen there. This is a very basic diagram of how the wave works in New Zealand. So basically we've got the Southern Alps. So I'll just draw on this quickly. We've got the Southern Alps sitting in here, and we get the northwest winds, or the westerly winds, which are our fairly standard winds we get in the South Island of New Zealand in particular, and also the North Island. So we think of this as looking north. We get the westerly winds coming in this way. They get forced up over the South Island, and this is where we get a lot of cloud and rain forming. So I think most of you know the weather system in New Zealand. We get a lot of rain on the west coast, but by the time the air comes over to the east coast, it's very dry, and we get much less rain on the east coast. So with that air getting forced up over the mountains, it's got no choice but to come down the other side. As it comes down, it picks up energy, and you get it bouncing back up into the air, back up, and that's what forms the wave. So this can happen behind any mountain. A small little ridge will do it, or you can think of the Southern Alps as a whole as just one mountain range, and you'll get these sort of wave clouds forming behind it. Often, like this diagram shows, you get the low level wave, which is what we're quite often flying in, or sometimes you can get the big upper level waves, which is, for example, the northwest arches like that. So this would be sort of a bit of an example of where you could get the northwest arch. I'll show you one of Terry's photos. So I'll just get rid of that, and I'll show you one of Terry's photos. So here's a classic photo of the Northwest Arch. This is one from Terry, and you can see when we do manage to get up into the wave in our gliders, we can fly really long distances. So Rangi's talking about flying 1,000 kilometers and wanting to go up to doing 2,000 kilometers. So if you can get up into these wave clouds and the stunning sort of environment up in our atmosphere, you can fly really long distances. So in the South Island, we get these stunning waves like this, and in the North Island we do as well. So I think I'll let Vaughan jump in now, and he can talk a bit about flying in the North Island.
Yeah, good day everybody, how we going? So the wave in the North Island compared to the South Island, I've done a lot of flying in Marama, and do a lot of flying in the wave up here in the North Island. And one of the biggest differences is, what I find is, the wave up in the North Island is a lot moister, in the respect it's wetter because of the atmosphere. It's not so much mountain ranges in the way, upwind of the sea, so it doesn't dry out as much. And one of the things you do find is, when you're flying in the wave in the Wairarapa and in the Hawke's Bay, you actually fly a lot closer to the roll cloud than what you do in the South Island. In the South Island, you seem to fly a lot further away from the actual cloud, whereas in the North Island you fly actually quite close to the cloud. So that's one of the big differences in flying in the North Island that we have here. So I'll probably just go back to what I usually do in my preparation, and basically I use MetView, so the VUW site and I use the upper air forecast charts. And what I'm doing is I'm going step by step up through the millibar levels, so through 10,000, 14,000, 18,000 and up, and just seeing what and how it's changing. If it's consistent all the way up, you're going to have a pretty good day. And if it's consistent in direction and speed, you're going to have a good day. So I use that, and I also use a Jetstream chart that I look at. I've got a little Jetstream chart that I can log onto, and that's telling me what the Jetstream is doing above, at the higher level to see if the wave is going to transfer up into the jet stream. So there's a couple of little things I use like that. Probably another thing I use is the TIFOgrams as well to see where the nose is on the chart. Basically, the more pronounced the nose on the chart where it breaks away from being stable to or unstable to stable when that transition area is, gives you a good idea of where and how high you need to get into the wave, or where you're what height's going to be the sort of the transition area into the wave. So there's a couple of things that I use. Personal preparation, I usually I'm planning a flight. So what that flight is, am I just going for a 500 cruiser, or am I going to go for a big mission thing? So from that, I use airspace, what the airspace limits are. I've got them pretty well memorized, what heights I need to be where, and what what heights I'm transferring through different classes of airspace. The use of oxygen, my oxygen systems, I take very good care of my oxygen system, making sure that it's always on the go. I carry spare batteries from my EDS. In the glider that I got now, I've got 2 oxygen bottles in it, and I can easily transfer from one bottle to the other. So that also helps as well. Is the weather shaping up the way that you're planning? So some of these long distance flights, and Terry's probably more of the gun and more of the ace on this, is that you're watching these weather systems probably a week, 2 weeks, week and a half sort of out, and just watching it change and seeing how it's progressing as it's coming onto the country. So if you're looking at a 1,000k flight, some of these flights you're looking at a week in advance at the weather and following the weather is it going to shape up, and is it getting moister or is it getting drier, and is there anything happening to that weather system that's coming in? The other thing to do is lots of water in the glider, lots of food as well, lots of snacks, lots of sugar as well, keeping your blood sugars high, and of course warm clothing, good thermals. I've got good pair of electric socks, helps the day, makes the day more bearable when you do go flying on these good days. So that's sort of my personal preparation. And if I am doing a long flight as well, probably one of the biggest things you do is, to get the airspace that you require to make it so it's not sort of a shock value to the air traffic controllers, is to actually give them a ring and basically give them an idea of you're filing a sort of a pretty loose flight plan of what you're trying to do or what you're trying to achieve, and the heights that you want to run at, and giving them the heads up so you're not sort of all of a sudden just blipping up on their radar screen and then asking to have the whole country as your playground. So that's quite important too. So glider preparation, is the glider good to go? Battery is good. Basically, I've put a little mark here: don't be a clown and get a clearance into airspace only to have your batteries go flat on you. Know your equipment is up to the job before you use it. So with lead acid batteries, I used to replace mine every 2 years just out of principle, and I never really had any problems because of that. Now I'm onto these LiPo 4s, which are fantastic, and I've had those for quite a few years, or about 3 or 4 years now, and they seem to perform so much better in the cold as well. So if you're going to be doing a bit of wave flying, and that's what you want to be doing, you've got to have the gear to do it. One of the earliest things I found with the glider preparation was years and years ago when I was flying my standard Cirrus. Back in the days, everybody used to lubricate everything with Vaseline. Well, Vaseline's really, really good for attracting water, and when you get high in the wave, all of a sudden your controls get stiffer and harder to work, and it's quite upsetting when you're at like 20,000 feet and all of a sudden the ailerons are getting harder and harder to work. So, and because you're flying at that height, usually once you're at that height, you aren't actually doing much control inputs. So you aren't moving the control stick that much, because usually, you're in the laminar and usually you're just trucking along. So one of the things I did with the standard Cirrus was I basically pulled the control circuits all apart, and I got a real low temperature performing grease. So I think of it as grease, which was good down to think it was down to like -40 degrees. And so I
Amiga,
re-greased,
Amiga grease, isn't it?
yeah, Omega grease, yep, and I re-greased
You
all of my
put me on
controls.
to it 20 years ago, Vaughan.
Yeah,
It's
yeah, and
excellent.
it's bloody excellent. It's really, really good. So yeah, I've been using that for a long, long time on all my gliders, and yeah, I've never had a problem since I've used that stuff. So it's been fantastic. Your water ballast, I fly with water ballast when I'm flying in the wave. Yes, there is the freezing issue, but when you're usually flying in the wave, you're usually pretty well bricked up, so it's pretty hard to freeze, 100 and 200 liters. So, but the problem with that though, if you're putting any water in your tail tank, of course, you've got to have the antifreeze in it. So when I'm flying in the wave, I have antifreeze in my tail tank, and usually about 1 liter of antifreeze I throw in there, and that helps that out. What else have I got here? Glider instrumentation.
Sorry, Vaughan, just before you go on, the important thing with carrying water ballast, I've got no worries about the water freezing in the wings. But as Vaughan said, your tail needs antifreeze, but you cannot dump the water. You've got to land with the water on. So if you've been up high at 20,000 feet for say 7 or 8 hours, and you try and dump your water, you may have asymmetrical dumping. And so you've got to plan on carrying the water to the ground. You try and dump it, and you might only dump one valve, so that becomes dangerous, with one wing heavy. So you've got to be prepared to carry that water to the ground. And that's quite a concern if you've got a land out situation into a small paddock, because you might have to approach at 80 knots. And now your ground roll's 3 times as long. So just a point.
Yep.
Sorry to interrupt.
Okay. No, that's all good. I had to actually further on in my little list of things here, so we'll catch up to that. But next item I've got is glider instrumentation. I've got basically when you're flying a wave, and if you're doing serious cross country and wave, you've got to have a turn and slipper or artificial horizon as a must, basically. And also have the training on that, being able to use the buddy instrument and using the turn and slip or the artificial horizon. In New Zealand, especially in the North Island, the cloud can close up so quickly on you, and you've really got to be onto it with these instruments. Also, I've got in there moving map. These moving maps are fantastic. Wave flying previously to these moving maps was a lot harder than what it is now. The moving map devices that we've got, Odys and LX9000s, just adds to the easiness of flying in the wave. One of the little tips that I always use is always have a when you're flying into a clouded area, always have an out, but also so have your artificial horizon ready or on, but also have on your moving map have a turn point that you want to be tracking to, so that when you are on the artificial horizon, that you're tracking to that turn point. So either it's to the west or it's to the east, or whichever way you want to go to get out of the problem that you've made for yourself. Airspace maps, we have to have those in for that very reason, for going cross country, and they've got to be up to date. Good radio, good transponder, good Vireo. You got to have a good Vireo that you can rely on to fly through all the crap here before you get into the good air. Also, good oxygen system and knowledge of how to use it. Enough gas for the flight you're planning. How much gas have you got? Or, you should be checking your gas every time you go flying if you're going to go wave flying. During the flight, weather, is it progressing as per forecast timings? Air mass is the air mass drying? Is the air mass wetting up, moistening up? It's very critical to keep an eye on that and watch that as the day is progressing and what you're trying to do. Also, I've got in here oxygen. Is it all good? Continuous. Is it flowing right? Are you getting flows? Have you got an oxidizer which you put in your fingertip to tell you what your oxygen levels are? I've also got in here like a continuous scan checklist. I don't know what Terry does, but I used to do it when I was in the Cirrus with the A8A. I used to go through a scan list every couple of minutes making notes of that. I've got flow on the flow meter, and then I just go around the cockpit just checking things. EDS is quite good because you can sit there and you can hear it, and you can every time you breathe, you hear the psst into your nose. So yeah, continuous scanning and a checklist of making sure that you are getting that oxygen flow, or the correct oxygen flow for the heights that you're flying at. Because if your oxygen goes wrong, it's going to turn into a hell of a mess for you, really. Also got here moving all control surfaces as to minimize freezing controls. I had an issue with my LS6 one time where it was filling up into the fuselage, and at 15 to 16,000 feet north of Mount Cook, running along on the wave, all of a sudden the elevator became hard to move. And then what I found out was that the wind tanks were leaking into the fuselage, and a big block of ice was actually on the bottom push rod, and it was actually encasing in ice. So I actually had to keep on braking it while I was flying. And once you have problems like that, I tell you, you get really quick at fixing them, because last thing you want is to run out of elevator authority. And so I've also got here water ballast. How long do you propose to fly? Be prepared to land full if on a long flight, as Terry just suggested before. Another thing is when you're on descent and landing with your water, you're assessing the dumping of the water. Don't force your dump levers, as you may break something, and be prepared to land with the water on. Descent and landing, gentle descent to avoid cracking the gel coat. Get the structure warm up gradually. Most gliders now are polyurethane, which does have is not as brittle as what gel coat is, but each to your own. I'm pretty gentle in my descent, so I don't want to crack my wings up. And also leave your oxygen on until you've landed, or you're happy or below 5,000. I usually either leave it on until I landed, or I get down to below 5,000, and I'm below 5,000 for a re-while. So that's a couple of things for me on my list. I've just got a couple of photos here as well that I'll share with you, and a couple of things.
Can you briefly just get on to flying the wave? You don't have to go into great detail, but just flying the wave up past Masterton, and how far north have you been? Towards Gisborne, and there's a few people looking at getting out to Yarraroa, Hicks Bay way, and what have you done up that way, and what can you tell us about that?
Okay, so in the North Island, you're really influenced, because usually when you're in the westerly flow, you're on the top end of a high, so you're influenced by slackening winds. Whereas in the South Island, you've got good winds all over the island. In the North Island, we have issues. Yeah, as I say, north of Guavas, or north of Napier, it's got to be quite a spectacular day that you actually get wind going all the way up. And in the North Island as well, in the Wairarapa, northwest is best, so northwest to westerly is best, but in the Hawke's Bay, it's west to southwest is the best to get the best waves. So I've got a few photos here that I'll flog, and a couple of satellite photos, which you'll sort of see. The biggest problem when you're flying in the North Island, let's see how we go here. You're already getting that? You got those, Alex?
Yeah, we're getting. Yeah, we got your screen. We got your screen there, Alex.
Okay.
Vaughan, yeah. Yep.
So I'll go through a couple of satellite photos here. If we zoom in, one of the biggest things when you're flying on the wave in the North Island is you can see the wave down here in the southern part of the Wairarapa. The biggest problem you have is in and around this area here. They've got the circle in the Manawatu Gorge. The Manawatu Gorge acts like a venturi. So what happens is it clouds out quite a lot of the time. So you can climb up out of Masterton or Greytown or whatever, get up to around about here, and then you've got 8/8 cover. And the 8/8 cover can be sort of like 80 to 70k long. So, but there is undulation undulations in the cloud, or the top level of the clouds, that you can run across the top of it, but you are flying basically over 8/8 cloud. And then as you get across into the back of the Ruahines here around Dannyburg, you can see the waves starting to go again. There's a couple other ones I'll flick into. And
of course, when we fly over 8/8 cloud, we've always got an out, either behind us, in front of us, or out to the east, and it's generally out to the east, isn't it?
Yeah, it's usually out to the east.
I mean, we never
yeah.
fly illegally, do we?
No, never fly. No, never fly illegally. It's, you know, you can, as you can see on this one here, you can just drop east. Further east, you've got more bars going down one. You can run along up into there and through and carry on. What usually happens though is the wave usually stops around here, Beam Napier, because the wind flow has just totally dropped off. And if you look on these satellite photos, you can see there's no wave up and behind the Kaimais or anything anything showing up into Te Araroa north of Gisborne. So there are, you know, you get a few good days where they do go the whole way, but then you get days like this, which is basically just the milk run. That's a 500k easy. You know, you do that in like, you know, 2 hours, 2.5 hours, 500k. But it also shows you where the waves, you know, it's 90% of the time it's like that. I'd say you're going to get 10% of the time that you can actually go further. I have been up north, up into around Waikaremoana, up into here, but the wave does. I've got some photos as well that shows it does go all bitsy, and it's all off high peaks that are actually getting good airflow over.
We've got some good questions here, and I think you're probably the man to answer this one. Georgia Schofield is asking, if you're on the ridge and you've climbed up as high as you can, what are you looking for as the markers to see if it's worth going over the back of the ridge to try and find the wave? And her words were, if you're on the ridge, what do you need to see before committing to going over the back of the ridge to find the wave, especially if there's limited land out options? Well, you've always got to have a land out option, otherwise you don't go. But maybe you can answer this, Vaughan, because you do it often.
I do it often, yeah. Basically, I'm just looking for a couple of things, and you got to have decent clearance between the cloud base on the ridge and the ridge itself. So you got to, I don't know, at least have 500 feet between the top of the ridge and the cloud. You're looking down. One of the biggest things to look for is the shadow on the ground. Where's the wave? Where is the wave shadow on the ground downwind of you? And then you can ascertain how far downwind you've got to travel to it. Is the wave actually in quite close because the wind's reasonably lightish, you know, 20 knots, 30 knots, or is it a way downwind because it's a buddy howler and it's blowing 60 knots? You've got to, yeah, that's basically how I do it. I go for visual, basically. If I can see a cloud and I can see a line and makes out, I'm off, you know, I'm just downwind, basically.
Vaughan, do you look for a low saddle to go through to minimise the sink, or and then head in to the lee of a larger piece of hill, or do you just blast over the top? What's your technique there?
Basically, where I go over on the Ruahines, and I'm basically going in. I basically go in. I've been Dannyburg Airfield, and Dannyburg Airfield's about 20k downwind. So that basically, if shit goes to shit, I'm basically on a long downwind into Dannyburg Airfield. I have done it at other places, but there's usually, you know, lots of paddocks and there's lots of clues to say that I'm going to get away with what I'm doing. I've done it at a Paraparam and gone all, you know, like 60. It was at about 40k downwind to go into the wave into the Wairarapa. But I've climbed to like 10,000 feet behind Kapiti to go across. So, yeah.
All right, that's great. Thanks, Vaughan. We'll just come back to you in a minute. And we've got more questions for you, but we'll just head on to Mike Oakley and just pick up on, he's going to pick up some of the loose ends, and he's got some photos also. And yeah, we'll come back to your photos in a mo, Vaughan.
Okay, sweet as.
Mike.
Good evening, everybody. we've all talked about the preparation and what we need to go gliding, and of course preparation is a big part of it. But at the end of the day, we've got to be able to get into the wave to fly it. So I'm going to talk a little bit about hopefully how we're going to get in the wave. And I'm just going to find my. Alex, can you remind me what to do?
Shift button down the bottom. There you go.
Here we go. Here we go. Find something a bit easier to talk about. Okay. Hang on a minute, just want to get a good photo. All right. So we talk about wave in New Zealand and what does wave look like. That's not the photo I want. This is probably a better one. This is a bit more advanced. Anyway, so we want to find out how to get in the wave, and I find the easiest place to get in the wave.
That photo hasn't come up yet, Mike. You might have it on the wrong screen.
Yeah, you need to share your whole screen, not just that window. Otherwise, we won't see any new windows that pop up.
How do I?
You might have to re-share the screen again.
Technically challenged here. Can you see that?
Yeah, there we go.
But I would like to actually move that one along. It's not the one I want. Anyway, that'll sort of do. For me to get in the wave, you've got either 2 or 3 options. One is find a rotor climb or a thermal to climb up into the wave. Go to a ridge which is sitting underneath the wave and use the ridge lift that gets you as high as you can and push into the wave. Or yeah, they're the 2 easiest ones. For those of you that have been to a Marama or Springfield, normally what happens is the wave will set up in the lee of the ridge, and the wave can either be marked by little rotor clouds or it can be in the blue. And normally what we'll do is we'll tow up, and normally you can get quite a bit of turbulence, or you can get quite rough on tow, and normally that's underneath the wave. Then you'll hit the sink of the wave, and then you'll run into the lift, and you normally get the rotor or the bumps just prior to getting into the lift. So we never get off in the sink, and we make sure we tow through most of the turbulence until we get to the turbulence drops off, and it'll either go smooth or it'll stay quite lumpy. If you get a really good gust, that's when we get off tow, and we treat those bumps or those gusts like a thermal, and we core the glider in and as best as we can and climb up. We're normally got quite a bit of wind around. We could have anything between 10 to 30 knots while climbing. So we've got to keep recentering ourselves in the best bits. If we fall out of the lift, we point the glider into wind until we get another really good gust. We wrap the glider around in it, get some more lift, and you just stick with what you got until you get up and the lift goes smooth. On a day when there's any moisture around, the cloud or the front of the wave will be marked by little wispy bits of cloud, or even possibly a lenticular or a roll cloud. And you keep working yourself up underneath the darkest bit of the cloud until you get to virtually cloud base, and then you'll push out in front of the cloud and into the silky smooth lift. Do you have any photos, Alex, that you might want to share as I'm talking, rather than me?
Yep, no problem.
As I'm talking, you can bring up the relevant good photos.
Yeah.
So we're now up in the wave, and you can see in this photo here, that's Alex got just to the right of his pointer there. There's one wee little bit of cloud, and that's a little bit of a roll cloud just upwind of Springfield. You just come down, yeah, that one there, Alex. That little cloud there. That sometimes on a day when the air's quite dry, that little cloud might be there for only 30 seconds to a minute, and you've got to keep looking around all the time for the indicators to show you where the lift might be. Otherwise, you could be flying around for ages trying to find the lift. We'll climb up in front of that cloud, and if you can see in front of that, above the cloud and out to the front, the wave actually is sitting out in front of it a little bit further. So once you get out of that lift, you would then punch forward into wind, and take the next climb until you get into the smooth air. Of course, when you hit the smooth air, you will be going up quite quick, sometimes anywhere between 1,000 and 3,000 feet a minute. So if you've got airspace coming up, you need to think about it well ahead of time. And all the time when flying in the wave, you need to think well ahead. You need to have your brain 10, 15 minutes, half an hour, or an hour ahead of where you want to be when you're flying. Because if you're not going to make the most of the day. So when you're climbing up and you've got your transponder on well before you need it, you call up well before you need it. When you finally hit the smooth lift, you get your clearance, you head on track. Normally when I call up for a clearance, I'll actually give the controller a plan of where I think my southern and northern turn points might be for the day, so that he's got an idea roughly which direction I'm going. And they normally won't bother you after that, because they know that you're going to go that far north and that far south, and quite often they'll just leave you to it. And I know when I did my 1500K flight, I got changed around about 7 controllers throughout the day, but no one, and they didn't really bother me at all. Anyway, this is it. We've climbed up and got onto that bit of wave. We've got what we call a wave bar here, or roll cloud, or lenticular. Well, it's not really lenticular, it's a roll bar. And we get on the front of that, and we treat that a bit like a ridge. And we just fly along that as if we were flying along the front of a ridge. How fast do we fly? How high do we fly? Well, that depends on the day and how much moisture there is around. If I was going to track along this in the direction we're looking, I'd probably fly reasonably quick, and I wouldn't slow down until I got to the highest bit of the cloud, which is on track there. Normally, the thicker the cloud, the stronger the lift. So I would go fairly quickly till I got there, because there's obviously going to be lift going all the way along here. This is probably only about 8 or 9 knots of lift. When I get to that other bit of the cloud, it's probably 10 or 12 knots. So why fly slow in the soft air when you can fly higher, slower in the fast air and climb quicker? On days like this, when we've got a lot of bit of cloud around, it tends to be a lot cloudier to the west, and there's parts of the country as you get further west, these wave bars that we've got here, what we call wave bars, actually start to close in and merge up. So you can't actually, and at times you can't actually see the ground. So the higher you go, the easier it is to see the undulations in the cloud. But on a lot of days when we get a lot of cloud, I don't tend to fly too high. I tend to fly about 1,000 to 3,000 feet above the cloud, and sometimes not even above the cloud. You're flying along in the depressions made by the wave, and that gives you the faster times. But sometimes a wave will bend around and it'll jump upwind or go downwind, and you have to look well ahead to work out when that's going to happen. And then those points, you need to climb higher so you can look down on top of the cloud and work out whether you need to go upwind or downwind. So this is a really good example here of the wave bars. But if you look to the north, it looks like it's really getting quite cloudy and filling in. So what you need to do is, when you get to the other end of that wave, you need to judge your speed so that when you get there, you're high enough to see where to go to next. How do I jump down upwind onto the next wave? If I know I'm going downwind, I don't tend to fly too high. If I know I have to jump upwind, I need to make sure that I'm high enough to be able to transition into wind. How do we transition? We transition at right angles, either straight into wind or straight downwind. No point in going across the wave on a diagonal and going through all that sink, which might take you 6 minutes when you could go downwind in 1.5 minutes. When going downwind, especially on a day when there's no markers, it's very important to make sure that once you've gone over the wave, back of the wave, you're going to a lot of sink, that you don't fly too fast and actually fly through the next wave downwind when it's blue. And a lot of people make that mistake. They fly too fast. They go, because they're doing a ground speed of over 250 kilometers an hour, say downwind, with a 40-knot tailwind, that they fly through the next wave bar in the blue and miss it. When there's a lot of cloud around, you must make sure, the guys touched on this before, you must make sure that you have an out, that if you're going to be flying over cloud, out more on the main divide, where there's a lot of moisture and a lot of cloud, that you do have an out. Your out is normally to the east, where the air dries out. And sometimes we can't actually, we think there's, if you're not high enough, it's very hard to tell whether there's actually gaps in the cloud downwind. So that's another reason sometimes where you need to get a little bit higher, make sure there is a gap downwind. And when you go downwind, you know exactly where you're going to be, that you're not going to be flying into a gap, which is in a valley, which is unlandable. If you do end up in cloud, you need to get out as quick as you can. Disorientation will get you, and that's why Vaughan said he always flies with an AH. I've never flown with an AH. I just make sure I stay away from the clouds. On moist days, you must be very careful when flying along a wave bar that the wave doesn't jump upwind or move. The moisture, the cloud moves upwind, and before you know it, you're actually engulfed in cloud. The first thing you do is turn into wind as quickly as you can, gently, so that you don't end up going into a spiral dive and losing it. Always stay clear of cloud also, because at altitude, cloud is moisture, and you'll end up icing yourself up. And also there's rocks in those clouds. Alex, have you got any photos looking with when you're looking along underneath the wave bar and you can see the shadows on the ground up ahead? If not, I can probably.
That's probably a bit too big a shadow, isn't it?
Yeah, that's a big example of one. When there's a lot of cloud around and you're flying and you want to know whether you can climb up and go up into the wave, sometimes you'll get you can look ahead and you can see the sun shining on the ground in the distance, and you know that there is, if you do go up in that wave and go along a bit of cloud that may be covering your track ahead, that you can actually, when you do get up there and fly to the north or to the south, that you do actually have a gap in the wave bar, and you're not flying over 8/8 to an unlandable place.
Okay, Mike, can we just open it up now? We can just have a few, we can have some questions direct, if anyone's got any questions direct to ask of our guest speakers there, either Rangi, Vaughan or Mike. And especially about the North Island too, because I know there's a lot of you guys from the North Island there, and you want to utilise that wave. So yeah, shoot, if anybody's got any questions, unmute.
Yeah, I've got one for Vaughan.
Yeah.
And that is, Terry, is it possible to join up the Kaimai wave with the Napier Hastings wave? Do you think?
Yep.
Yours, Vaughan?
Yep. Sure is. The problem is, the thing I can see with it is that the Kaimai wave's only good in the southwest. So you basically, the perfect day that you're looking for is southwest on the Kai, so you can jump over and then come down through the Hawke's Bay. But when you're coming down into the Wairarapa, you really want to either be west or northwest, so it's backing around. So it's an unusual weather system to be looking for. Maybe you might get it post frontal, after the front's gone through, and you've still got southwest up there, and you've got northwest down in the Wairarapa. The southwest wave in the Wairarapa is absolute crap. It's just as rough as anything, and it's just horrible, basically.
Well, Vaughan, there is a weather system that will support it, but we don't seem to get them very often now. And so most of the wave flying we do is out of a anticyclonic flow. So as you go further north, the winds decrease and the flow goes more northerly. But if you come out of a cyclonic flow, like a depression,
yeah,
and we used to get 3 of them a year, but the weather systems seem to have temporarily got COVID or some bloody thing, because we don't seem to be getting them. We did get these huge cyclonic flows which would give you northwesterlies in the in the southern latitudes or the South Island, and then it would go around to a southwesterly in the northern part, in which case I had this idea that I was going to go from the Wairarapa wave across to the lee of, help me out here, the one by Tauranga. What's the big one in the middle?
Right.
Ruapahu.
Ruapahu, yeah, Ruapahu, and then from Ruapahu onto into the back of the Kaimais, because as you say, you need the southwesterly for the Kaimais, right?
Yeah.
And then from the Kaimais up to Coromandel, but that's pipe dream stuff. So I think you've come to the same conclusion as I have, but have a look at it for all the North Islanders and let me know what it looks like in a cyclonic flow, like a clockwise flow, a big depression, because you get these big dry depressions that come out, and it's normally at the end of autumn and at the end of spring, at the end of summer. Yeah, at the end of autumn and at the end of spring.
We've got a couple more questions on the chat here. Felix asks, what is acceptable for use as a landmark when contacting ADC? Visual reporting points in towns or more? I'd say visual reporting points.
Usually when you look on your map, there are various names of towns and all sorts of things. So I guess if you reference one of those, then that's on your aeronautical map, that is. That should do them.
Carl asks, transition between islands. What are target heights, north and south? Terry, you've done that a few times.
40,000 feet. high as you can. The minimum's about 20,000.
Terry, you were talking before about depressions and the westerly flows that come off them, and I quite agree with that. Some of the best flights I ever had off a cyclone, and that's mainly because there's that much more moisture, and you end up flying a little bit further to the east, but they tend to be a lot better marked, and the winds tend to be on a slightly better angle depending on how high the depression is. But you only get a very short window for a weather system like that, rather than a big high where you could get 3 or 4 days anticyclonic or west weather. And I know that Dick Georgeson used to recommend, if you had a big high, he reckoned always the third northwest day was the best one.
All right. Okay. If there's no more questions, I'll put it back to Tim.
Can I
sorry.
butt in?
Yep.
Adrian here. Just I noticed with Vaughan's satellite photographs, the second one showed the wave system up around Tauranga, down over Taupo, and the northwest in the Wairarapa on that second satellite photograph. If you look again, the Vaughan displayed, not the first one, but the second one. Of course, it's a lot cloudier around Tauranga, but you can clearly see the wave bars. You can see all the fawn gaps in the overcast.
You going to bring that up, Vaughan?
Hang on, I'll just try and see if I can get it.
All right.
That one?
I think it was, no, not that one. It wasn't that one. It was the second one that you showed, whichever one that was. Oh, there you can see them there.
Yeah, there's a wave going there behind Ruapahu and going up the west of
Going up. That's
Tiri
right. But if you look
Rapanga.
at the Coromandel, that's a typical wave pattern up there.
Is it?
Yeah.
Okay.
This wave runs all the way to the tip of the Coromandel quite comfortably with almost no gaps in it.
Yeah.
But you can actually see it's just not lined up with the sort of northwest wave you get in the Wairarapa. But I know that you've actually been to Ruapahu on one contest day in Taupo. I think there were 3 or 4 of us went, and we went round the sort of Crater Lake and came back in the wave from Taupo. That was, I'm sure you were.
Yeah, no, I've been to 17,000 behind Ruapehu, and
Yeah.
I've we actually got photos on here just Easter and even Easter as well. Easter just gone, I flew up, climbed in the back of Turangi to 9,000, then ran up the ran up the Western Lake up to Biddy, is it Tiri Rapanga or whatever it is, Tim?
Well, you've got from Tauranga, the wave sort of peters out about Nakuru, which is a visual reporting point, sort of south of Rotorua, and it gets very, very weak there. But I'm pretty sure it will be possible for somebody who's determined to join the dots.
Right. Someone's asking the question, do you ever get wave off a coastal ridge like Raglan or along the coast?
You get pressure wave. Paparam was very good for it. You get pressure wave that goes up and it just pushes up the front of the ridge. And one of the local ridges just north of Paparam, you could climb to some days to 10,000 feet on it.
Yeah. So what kicks the wave off is not really the air rising on the ridge; it's the air descending down the lee side, is what kicks is the trigger for the wave. So if the wind was blowing offshore, you might get a wave actually on the lee side of it out to sea. So the air doesn't have to rise over the hill; it only has to drop down the other side. So the hills with the steepest drop away have the best, create the best wave. In fact, if the air mass is slowly rising and then suddenly descending, you'll get a better wave than the air rapidly rising on one side and then slowly descending on the other, if that makes sense.
Yeah, hence the Dunstans and the Pisas.
Yeah. All right, Tim, have we done enough?
Yeah, I think so. Any final questions? You can either type them in or talk.
Kawhatau was one of the situations where you got the wave in front of the hill. Or
Right.
pressure wave.
Vaughan, you going to answer that one?
I was just saying that Kawhatau was one of those places where you could get the pressure wave and then jump over the back.
Yeah, Paparam and up in Kawhatau, there are areas where you do get the pressure wave that does enable you to climb up high enough to jump over the back. And I'd say
Daniel asks a very
you'd get it in
serious
the Kaimais
question.
as well, wouldn't you?
Sorry, yeah, you can. Other questions? Daniel asks, recommended P systems for wave. Do you have any trouble with things freezing?
I use 2 plastic bags.
Yeah, I'm the same.
I use a P tube. I've never had it freeze.
Yeah, you'll only do that once.
Yeah, that's right.
Tony asks, is there anywhere in the North Island where you might get into wave below 10,000 feet?
Yes,
That's not-
Taranaki Gliding Club around Mount Egmont and the Ranges.
Yeah, Greytown in the southern Wairarapa.
Yeah, and Matamata, you can easily be in wave at 6,000 feet, 7,000 feet.
Off
So you can
1,700 feet
Right.
straight off the winch into the wave at Greytown.
Yeah, the nice thing about the wave is it comes down quite low to the ground quite often, so you can practice getting into wave at lower levels quite often.
And some of the nicest wave flying is in the winter too. You haven't got that all that unstable air. You get that nice laminar flow. You can get into the wave easier, and once you're in it and stay in it, it can be really nice but cold.
I got a question. Is Pat Dreesen listening in tonight?
I saw it on there.
Okay, well, Pat's here. Ripper. Tim, can you get Pat to talk about his thermal flying and his large task flying for next week's webinar?
Oh, I'm sure he'd be delighted.
Fantastic. Patrick, you're the man. It's awesome.
Thanks, Patrick.
Hands up those who want to hear from Patrick next week. Oh, look at that.
And his flight from down the Kais into the Hawke's Bay Wave as well.
Yeah.
Yeah.
Yeah, that's a whopper. Yeah, that'd be cool.
Frank asks, what's the latest on ADSB for gliders? That's a whole nother topic. And GNZ will put out something about that again soon. We did in the last one of the GNZ newsletters a little while ago. There was some updates on that, and I don't think a lot has changed since then. So, all right. We'll wrap
Good
things
night,
up.
everybody.
Thank you.
Righto.
Thanks everyone for coming, and keep an eye on the Facebook page, and we'll email out if we're doing another webinar next week or something.
Thanks, everyone. Good job.
Thank you.
Yeah,
There you go.